Hey guys, welcome back to AlgoYogi. We are doing two-pointer series, and our next problem in the list is merge two 2D arrays by summing values. So let's go to the LeetCode. Quite a lot of description, but I think it's very easy. So you're given two 2D integer arrays, nums1 and nums2, and nums1 ith index contains two values. Basically it's a 2D array, so it's id and value at one index, and nums2 contains the same thing. Now we gotta, every id is unique. That's a good information. They're already sorted by id in ascending order, so increasing order, and they're sorted by id, this 2D arrays. So nums1 is one 2D array and nums2 is another 2D array. Both are sorted and they contain id and values. Now merge the two arrays into one array that is also sorted in ascending order. So that's our job. And so basically we're creating a new, here there is no restriction of using constant memory. We will be basically just creating a fresh new array and going over both of these arrays and just utilizing their values. All right, and then if they have common key, we're gonna sum up. That's why it's called summing. So we're gonna sum up the values and keep the id same. So that's it. I think it's gonna be a straightforward problem. So, but still, let's see how we're actually going to approach it. So this is nums1, contains keys and values, and this is nums2, contains keys and values. Now basically for same keys we'll be adding these values. So otherwise whatever has the shorter key, so this one. So let's go over the result. So this will be result array, and initially since they have same keys, so first value would be 1 and 1 and 6. Then now out of these two we will have the smaller key, because we're creating a 2D array that contains values in ascending order by the key. So key here is smaller, that will be 2 and 3. Then we have 3 and 2. Finally this is also same. If they are ever same, then we just add these. So this will be 4 and 6, and that is going to be our result array. But we got to make sure not always they will have same length. So we'll make sure that once one of them gets exhausted, so we can have like 2 pointers. That's why it's categorized as 2 pointers. So if we're pointing it by pointer 1, pointer 2, and if one of the pointer gets exhausted first, that means there were some like less number of arrays, or one was covered before another one. Then we just basically take the remaining values from the other one, and then we just place it right into our result, because that's already sorted. One of them gets exhausted. We were perfectly following the respective order of ascending values, and that's it. And then we just return the array. This will take basically no constant space. So time complexity of big of n plus m, where let me just switch. So time complexity of big of n plus m, and space complexity of also same, m plus n, and m are the length of nums1 and nums2. Okay, so let's have 2 pointers, point 1 and point 2. This time they're going to be 0. It's just like merge sorted arrays, but it's 2D arrays. All right, and this time we are allowed to use extra memory. So it's going to be 0 0. Now we have a result array that is going to store our result. And then we will have while loop, because we don't know these the length of nums1 and nums2, and which one has more values, which one is greater than what values. So we're gonna have like, if p1 is less than equal to, let's do n comma or m comma n len nums1 and len nums2. All right, and also if this is p1 is less than m and p2 is less than n, that means our values p1 and p2 still points to values that are not exhausted, they're not used completely. So now is when we start comparing these values. So first thing first, if nums1, let's say nums1 p1, and since they are ordered by key, so key is placed at 0. So if this key is smaller than nums2 p2 and 0th index, that's where the key are stored. Okay, let me zoom in so we can focus on the code here. All right, looks nice. So if this is the case, that means result dot append will take basically nums1 at point 1. Okay, and else if the other thing, which is basically if nums when value is greater than nums2, that means we will place nums2. Okay, now that's all. How about else case? That means they're equal, and we talked about it. If they're equal, that means we will append by summing up the values and keep the key, any of the key. Okay, so it will be basically, let's place this inside a 2D an array value, and first thing would be just the key can be taken from either nums1 or nums2, doesn't matter. So let's take it from nums2, and that will be at 0th, but then we're gonna take the values of both arrays at index basically p1, so p2 at 1, and then p1 so nums1 at p1, and value is placed at basically this first index. So 0 is key, first is the value. All right, what if one of it gets exhausted, gets used, and there are some values remaining, so they were already in sorted order, that means the other one was already fed into the result. Now it's just if p1 is less than, if it is less than m, if p1 is less than m, that means we have some remaining values and that we just want to append it to our result. So result plus, and that's like nums1, and what will be the remaining value of it? Basically starts at p1 and whatever remains in p1, okay, in the remaining array. And same thing we will do with p2. That is like checking in if p2 is lesser than n, that means all the values haven't been used. So whatever remains in nums2 at index p2, including, because it was already incremented here, sorry about that, we forgot to increment p1 over here and increment p2 over here, that's a mistake. And at this place both of them gets used, so since their values were added, so both of them were used, so we need to increment both pointers. And here if any of them are lesser than, basically what if they're equal, that means the last element needed to be used, okay. And now I'm just thinking, what if they are equal? if it is less than m. Okay, I think this will work in that case, and now we just return result. Okay, let's run it on examples. We have some issue here, and that is indentation, just a little bit. So okay, now it's perfect. All right, I think this passes the test cases. Let's submit our answer. All right, 100%. All right, so let's talk about the time complexity. Now you can see the solution. I don't have to go over it again. It's just like merging two sorted arrays, and that too like into a new memory. That's the easiest thing, right? Now it's time complexity, and we already said it was n plus m, where n and m represent the length of nums1 and nums2. Space complexity is big of n plus m again, and it will worst case this, but it will always be shorter because there will be some common keys, right? Common keys, so that means we were summing up their values. So I think space has will be, worst case this, and average case just all common values and just max of n RAM. I think it's okay to talk about this in detail, because it shows that you were thinking and not just following some script or something. Then let's mark this done and see you guys in the next problem. Until then, bye bye.